For this problem, we're given f of x is equal to 10e to the negative x power, and we're asked to find the first four non-zero terms of the Maclaurin series for the given function, write the power series using summation notation, and determine the interval of convergence for the series. Okay, so the first thing, let's start with A. We want to find the first four non-zero terms. So we have the Maclaurin series written out here. So you can see that here's the first term, f of 0, and then we have f prime of 0 times x, and f double prime of 0 divided by 2 factorial, and so on. So we are going to want to take a few derivatives. I mean, even if the first four terms are all non-zero terms, we still need the first, second, and third derivative. So let's go ahead and do that to start. All right, so if f of x is equal to, I'll just write that down again, f of x is equal to 10 e to the negative x, then f prime of x, the first derivative of that, remember the derivative of e to the negative x power is negative because you take the derivative and bring it down. So the derivative of negative x is just negative 1. So it becomes negative 10 e to the negative x. Okay, and the second derivative, again, you take this derivative and it becomes a positive when you take the derivative of negative x and bring it down. So 10e to the negative x. And you can see the pattern here. The third derivative is going to go back to negative 10 e to the negative x. Okay, so you can see the pattern there. You don't have to keep taking those. You know what it's going to be. Every odd power is going to be, every odd derivative is going to be a negative 10 e to the negative x. Every even power is going to be a positive 10 e to the negative x. Okay, so now let's plug in, well, let's start finding these terms. So the first term is going to be f of 0. So we plug in a 0, and let's see if it's our first non-zero term. So f of 0 is equal to 10 times e to the negative 0 power. Okay, so negative 0 is the same as 0. Anything to the 0 power gives us 1. So that's essentially 10 times 1, which is 10. Okay, so that is the first non-zero term. Okay, so then we have f prime of 0. So let's see what that is. And remember, this f prime of 0 is also going to have an x on it. So we will include that in our term. But first, let's figure out what f prime of 0 is. So we would plug that into here, and we get negative 10 e to the negative 0, which becomes negative 10. Okay, so you can see that it's just going to go back and forth between 10 and negative 10 when we plug in a 0. Okay, so that makes f double prime of 0 equal to 10, and f triple prime of 0 equal to negative 10. Okay, so we can write the first few terms, and it looks like all four of them are going to be negative, or are going to be non-zero. So you can see here 10, negative 10, 10, negative 10. They're all non-zero terms. So the first four non-zero terms are going to be, the first term is going to be 10 plus negative 10x, or minus if you want, plus, it's a positive 10 x squared, and then plus a negative 10 x cubed. And whoops, let's not forget our factorials. I did forget the factorials. So the third term is going to be divided by 2 factorial, and the fourth term would be divided by 3 factorial. So let's divide that by 2 factorial and 3 factorial, just so we can keep with the actual formula here. Okay, so those are our first four terms. We can clean those up if we want, and we do. So the first one is still 10 minus 10x plus, let's see, 2 factorial is just 2, so 5x squared. And then 3 factorial is 1 times 2 times 3, so that'll end up being minus 5x cubed over 3. Okay, so those are our first four non-zero terms. Okay, so moving on to the second question, it says write the power series using summation notation. Okay, so in order to write the power series using summation notation, we have to see the pattern here. Okay, so you can kind of see the pattern from here. The 10 and the negative 10 are going to oscillate. We've talked about that. They go from 10 to -10. So that we can write by, we can say 10 times -1 to some power, because if you raise it to some power, it's going to make this go back and forth as it gets bigger and bigger power. It goes even, odd, positive, negative. So we'll say to the k power, okay, and that's assuming that we're going to start with k equals 0 to infinity. Okay, so if we do that, we plug in a k here for 1 or 0. Let's make sure it works. It should give a positive term. So anything to 0 power is positive. That works. Our next one would be a 1 to give us this term. Okay, so we need it to be negative. -1 to the 1 power is negative. Our next term will be positive next term. So that's fine. The top is fine. Okay, and then we also have, how do we get our x's in there? Well, the first one doesn't have an x, or you could say it had an x to a 0 power, x to the 1 power, x to the 2 power, x to the 3 power. So that's going to be x to the k, because our first one is going to be to the 0 power, which works. Okay, and then divided by, we're dividing by just like up here, you can see that the pattern is, this would be 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, so it's k factorial. Okay, so that's B. Okay, and now for C, let's go up here and read it. Determine the interval of convergence for the series. Okay, so in order to determine the interval of convergence for this series, we're going to use the, and I'm running out of paper, let me get a new piece. We're going to use the ratio test. Okay, so ratio test. Okay, so the ratio test says that if you have, you're looking for an interval of convergence, and if you have the sum of the absolute value of a sub k, this converges if r is equal to the limit as k approaches infinity of a sub k plus 1 divided by a sub k if it's less than 1. Okay, so we need to figure out where that radius of convergence is. So we're going to set up this and take the limit as k approaches infinity. Okay, so limit as k approaches infinity of, let's write the top part, which would be everywhere you see a k, you put a k plus 1 instead. So it's going to be 10 times -1 to the k plus 1 times x to the k plus 1 divided by k plus 1 factorial. Okay, and the ratio test says divide, but since I'm going to be dividing by another fraction, okay, I could put a divide and I could put the fraction, it would just be this stuff. I could put it right here. But since I'm dividing by a fraction, I'm going to save myself a step and flip and multiply it. So instead of putting this all on bottom of all this, I'm going to put it out here, except the k factorial was on bottom, now it's going to go on top, and all this stuff was on top, it's now going to go on bottom. So you could write out both steps if you wanted, but that's just saving us a step. Okay, so let's clean that up and see what we can do with that. Let's see, the first thing I would note is that the k plus 1 factorial, let me write this in a different color, k plus 1 factorial is the same thing as k factorial times k plus 1. Okay, so you can watch one of my other videos that I'll explain that a little better in a different video, but this is what it's equal to. Okay, the reason we want to write it that way is because we have a k factorial up here, and we'll also have a k factorial down here, which would only leave the k plus 1. Okay, so that's one thing that we're looking at. Another thing that we're going to look at is that x to the k plus 1 is the same thing as x times x to the k, because this is the 1 power, and you add them up when you multiply. Okay, why is that important? Well, it's important because that would give us an x to the k and an x to the k that we can cancel out. Okay, and also -1 to the k plus 1 is equal to -1 to the 1 times -1 to the k. Same reason we can cancel it out there. So there's a lot of cancellation that's about to happen here. The first thing we can look at is, well, we've got those 10s that can cancel out. Okay, so let's rewrite it before we cancel. So the limit as k approaches infinity. Got rid of the 10. So I have negative 1 to the 1 power. I'm not even going to write the 1 power. Times negative 1 to the k. And then x to the 1 power, not going to write the 1, times x to the k, divided by k factorial times k plus 1. Okay, that takes care of the first fraction. Okay, and then over here, everything is going to remain the same. Negative 1 to the k, x to the k. There we go. All right, so let's reduce some things. The negative 1 to the k's, the x to the k, the k factorial. Those are all going to reduce. Okay, so that's going to give us the limit as k approaches infinity of negative 1 times x, so negative x. Is there anything else on top? Doesn't look like it. Divided by what's on bottom? K plus 1. Okay, so looks like everything canceled out, and we can go ahead and take this limit. Now keep in mind that, keep in mind that the negative x is considered a constant, okay, because that's not what we're taking the limit towards infinity. It's k is our variable here. So this is, for us, is just going to be treated as a constant, so we can pull it out front. So that would be negative x in an absolute value, and negative x in an absolute value is the same thing as positive x in an absolute value. So I'll just put positive x times the limit as k approaches infinity of 1 over k plus 1. Okay. Now, as we're sending that to infinity, do we need the absolute values anymore if k is going to infinity? This thing's growing without bound, right? So we don't really need that. But we can tell either way, absolute value or not, we can tell that the denominator is getting huge as it goes to infinity, which means this whole fraction is going towards 0. Okay. So this right here goes to 0. So what we get is the absolute value of x times 0. Okay, so what that tells us, that's going to be 0, right? Anything times 0 is 0. So what that tells us is that the interval of convergence, it doesn't depend on r, because, or it doesn't depend on x, excuse me, because x is going to get multiplied by 0 anyways. So our interval of convergence is not restricted. There are no restrictions on the interval of convergence. Okay, if this was not 0, if this was some other number, then we would set that less than or equal to 1, and we'd solve it for x. But this is going to be 0 because it gets multiplied by 0. So there's no restrictions on the interval of convergence. What does that mean for our answer? Well, if there's no restrictions on the interval of convergence, because there's no x now, it got sent to 0, then the interval of convergence is everything. Which means this thing is always going to converge. And that's it.